Can a 65-kilogram humanoid robot really sprint at nearly 20 kilometers per hour while controlling 48 independently moving parts across its body? Standing 173 centimeters tall, the Galbot ET1 places 24 of its 48 degrees of freedom, exactly 50%, inside its hands for precise physical work. Unveiled in August 2026, this humanoid combines fast movement, flexible hands, and advanced computing in a machine designed for the next generation of industrial robotics. The Galbot ET1 is Galbot AI's first fully bipedal humanoid, unveiled at the World Robot Conference 2026 in Beijing. It stands 173 centimeters tall and weighs around 65 kilograms, with a human-like design for easier workplace integration. The robot targets manufacturing, automotive, and industrial automation, combining mobility with physical task handling. The ET1's two-legged design allows movement through stairs, narrow spaces, and workplaces built for humans. Unlike fixed or wheeled robots, it can potentially move between multiple workstations without major infrastructure changes. Balancing a 65-kilogram robot on two legs, however, requires highly precise control of movement and stability. The ET1 has 48 degrees of freedom, allowing independent movement across its body and joints. Its hands alone contain 24 degrees of freedom, exactly 50% of the robot's total movement capability. This high joint count focuses on mobility, balance, and precise manipulation. The ET1 uses 5-fingered hands with 24 degrees of freedom for flexible object handling. It reportedly supports a 15-kilogram payload, equal to roughly 23% of its 65-kilogram body weight. This makes it suited to sorting, material handling, and light assembly, rather than heavy industrial lifting. How fast can it move? The ET1 reportedly reaches 20 kilometers per hour, compared with a 4 kilometers per hour walking speed, making its sprint roughly 5 times faster. Running requires constant control of balance, force, and body position across the entire robot. While factories may rarely need sprinting, fast movement demonstrates the ET1's dynamic balance and response capability. The Galbot ET1 has been demonstrated training for tennis, which is far more difficult than simply moving an arm back and forth. The robot needs to detect a moving ball, calculate its position, move its body, and control its arm and wrist at the correct moment. Galbot has reported glass-to-action latency below 100 milliseconds, which is less than 1/10 of a second. That speed matters because delays can make the difference between hitting a moving object and completely missing it. Tennis therefore becomes a useful test of perception, timing, and balance, all happening together in a single activity. The ET1 uses Galbot's AstraBrain embodied AI system, which connects visual understanding with physical movement. The robot needs to recognize objects and understand where they are located before calculating how its body should interact with them. This approach combines vision, language, and action, allowing information to move from perception to physical control. The reported reaction target of under 100 milliseconds is especially important for tasks involving moving objects or unexpected changes. The goal is to give the robot more flexibility when its surroundings are different from a previously planned movement. The Galbot ET1 uses onboard computing based around NVIDIA Jetson Thor, providing processing power for visual information and robotic control. Its software is Linux-based and supports ROS2, which is widely used in modern robotics development. The machine also supports over-the-air updates, allowing software capabilities to improve without replacing the entire robot. Wi-Fi and Bluetooth connectivity could help the machine communicate with other systems inside a workplace. That means future improvements may come through software rather than requiring a completely new physical robot every few years. The ET1 reportedly operates for around 2 hours on a single charge, and this remains one of the biggest limitations of humanoid robotics. An 8-hour work shift would therefore require roughly 4 operating periods if the robot worked continuously at the same battery capacity. Walking and balancing consume significant energy because multiple motors must constantly control the robot's position. Cameras, sensors, and onboard computing systems also require continuous power. Future deployments may require battery swapping, automatic charging, or multiple robots working in rotation. Galbot is positioning the ET1 for industrial automation, manufacturing, and automotive environments. Unlike traditional industrial robots that often remain fixed in one position, a humanoid robot can potentially move between multiple workstations. Its 15-kilogram payload capacity could support the movement of materials and lighter components around a facility. The combination of legs and flexible hands may allow one machine to perform different tasks during the same working period. This flexibility could become one of the biggest reasons companies consider humanoid robots instead of installing separate machines for every job. The Galbot ET1 has an IP54 protection rating, offering a level of protection against dust and water splashes. The first number, 5, refers to protection against dust entering the machine, while the second number, 4, refers to protection against water splashing from different directions. This does not make the robot waterproof, and sending it into heavy rain would be a very expensive experiment. However, the rating suggests that the ET1 is being developed with practical working environments in mind. Protection against dust and accidental splashes becomes important when robots move beyond clean laboratories and into industrial spaces. The ET1 supports 2.4 GHz and 5 GHz Wi-Fi, along with Bluetooth 5.2 connectivity. These systems could allow the robot to communicate with factory networks and receive information from other machines. Connected robots could potentially share operational data and work as part of a larger automated system. The support for over-the-air updates also means software improvements can be delivered remotely. As factories become more connected, robots may eventually operate as coordinated groups, rather than completely independent machines. The Galbot ET1 has been associated with an indicative price of around $95,000, although it is still considered a prototype. For an individual, that is the price of an extremely expensive robot, and probably an extremely awkward conversation with the bank. Industrial companies, however, will measure the cost against productivity, maintenance, and the value of the work performed. The purchase price is only one part of the equation because servicing, software, and infrastructure can increase the total cost. Commercial success will depend on whether the robot can produce enough useful work to justify its long-term operating expenses. The humanoid robotics market includes companies such as Unitree, Agibot, Fourier Intelligence, Tesla, Figure, and Boston Dynamics. Different companies are focusing on different strengths, including speed, manipulation, industrial work, and general-purpose automation. The ET1 attempts to combine athletic movement and dexterous hand control within one platform. Its reported 20 km/h sprint speed is paired with 24 degrees of freedom in the hands, creating a balance between mobility and manipulation. However, the robot industry will ultimately reward machines that can perform reliably rather than simply produce impressive specification sheets. The biggest question surrounding the ET1 is long-term reliability, because the machine is currently still a prototype. Performing a task once during a demonstration is very different from repeating that task thousands of times inside a factory. Its reported 2-hour battery life also limits continuous operation, while its 15-kilogram payload restricts the type of heavy work it can perform. With 48 degrees of freedom, the robot gains flexibility, but every additional joint adds more mechanical and software complexity. The real test will begin when these machines are expected to work for long periods without falling, stopping, or requiring constant human assistance. The Galbot ET1 combines 48 degrees of freedom, a 15-kilogram payload, and a top speed of 20 km/h, showing how humanoid robots are becoming more capable. At 173 centimeters tall, it is designed to work in environments already built for humans, rather than requiring completely new infrastructure. Although still a prototype with challenges in battery life and reliability, the ET1 points toward a future where humanoid robots could become regular workers in factories. If you enjoyed this video, don't forget to like, share, and subscribe to our channel.